Well, thanks for joining us, everyone. Appreciate you coming back for another ATS University. If this is your first time, my name is Zach with ATS. Zach Allon. I'm our national account manager, and I work with engineers across the country to help get them set up on the ATS Spec Tool, which, if this is your first time, ATS Spec Tool is a product selection tool sponsored by a variety of manufacturers like Watts, who have their products on there to make it easy to configure, select, and then download an output spec that you can use either on your drawings or in your written spec, or even fixture schedules in Revit, all configured and customized to your product selection. We also host a number of learning sessions, both whether it's in person doing lunch and learns or online doing these webinars. We've done a number of these ATS University sessions over the last few years, and I'll show you how you can find them on the ATS Spec website later on the session. But with me today is Michael O'Brien from Watts Canada, the Blucher product manager in Canada. Blucher, as you'll find out, has a host of products, but mostly we're talking about trench drains today. And I think we're talking more generics, not necessarily specific to the Blucher line.
That's correct.
So Michael's going to be running us through everything you could possibly learn about trench drains. This is a ASPE accredited CEU, so we will be sure to have the Watts team register you so that you can report your CEU hours. And if you're in Canada, everyone will also receive our generic certificate of attendance that we send out. So if you are doing self-reporting based on your province or your state or whatever accreditation, we'll have a certificate of attendance sent out to you as well, so you can add this in. I guess without any further ado, I'll pass it over to you, Michael. Thanks for joining us today.
Great. Thank you, Zach. And thank you everybody else for joining us on a lovely day here in Southern Ontario, where we have gale force winds and rain coming at us sideways, but it's warm inside and dry inside, so we'll persevere. So today's objectives: at the end of the course, you should be able to identify applications where trench or linear drains are preferable to standard floor or point or area drains. Highlight relevant selection considerations for yourself and for your customers and contractors. Describe the different types of trench drain systems, their advantages and their weak points. There's no real, one size fits all here. So there's trench drains designed for specific applications. So you should be able to educate specifiers on how to evaluate potential performance and durability of a trench drain system, and provide specification guidelines to help installations run smoothly and produce a functional, cosmetically appealing finished product, and one that actually drains water and solids. So today we're talking about trench drains, sometimes called channels, sometimes called channel drains, sometimes called trough drains, linear drains, and as opposed to a point drain, which is a single point in the floor. So running along a line, as you see, I think the drawing here is pretty self-explanatory. Typically, these are poured in a concrete slab, so and most often they are indoor applications. There are other classes of trench drain for irrigation and roadways and bridges, but they're typically not specified by an MEP engineer. So we won't be covering those today. We're talking mainly in inside commercial industrial type of trench drains. So why trench drain? Two main reasons. First is the faster removal of surface water. In outdoor sporting facilities, amphitheaters, courtyards, walkways, swimming pools, factory floors, anywhere where water could cause a hazard and you want to have it removed as quickly as possible, a trench drain is a very good solution. And number two is for indoor floor cleaning. It's more efficient to push water and solids to a line of trench drain than to one single point drain that's could be several hundred feet away in the in the facility. So businesses like auto dealerships, medical facilities, breweries, pet housing facilities have traditionally washed floors daily, sometimes even several times a day. And for them, the speed in removing that and getting those liquids and solids off the floor is very important. So we're starting to see a lot of expansion in that market. So even non-sanitary manufacturing facilities are starting to install trench drains. Distribution and processing facilities, FedEx, UPS, Amazon. If they need to clean the floor quickly, it's much more efficient, again, to push that to a trench drain. The other advantage is that there's a lot less slope in the floor, so there's some safety there. It makes it easier to place equipment if there's not complex sloping. So we're starting to really see this market take off. So there's different types of installation. On-grade installation is typically the most common. Occasionally we'll see it where it's above grade, so it's on maybe a second or higher floor, and they have some other factors that need to be considered. But most common is that it's an on-grade installation. They use things like rebar and threaded rod supports to level the channels. It can be, in the case here where it's a wide open pit, they would use rebar and channel. But if they're, say, retrofitting, they could cut out a section of the floor that's a good amount wider than the trench drain they're trying to install, and then support it with something like unistrut across the opening and down from the top. So
I think
really,
one of the questions that I get asked all the time is how much concrete do they need either on the side or underneath?
So underneath, you probably 4 inches is a good rule. And then you'll need whatever space you need to get that concrete underneath and make sure it's fully supported underneath the channel. And if you're tying it into another floor, you'll have sections of rebar that you need to get in. So on a 6-inch channel, I might see quite commonly at least 18 to 2 foot of excavation to put that in, to give room to get some rods into the existing slab to tie in, to give room to work underneath and get it properly supported. So again, that's the 4-inch underneath is a harder rule than the amount on either side. But really, you're trying to make it all part of the floor or part of the surface. So the more the better. So trench drains have evolved over the years. They started out just as a poured keyway. I still see that being used in some places. In some places where it really shouldn't be, but that's where the concrete contractor that forms that into the floor, and then they source separately the grates to fill that area. So as you can see, it's not really that pretty. So for a parking lot, it's probably fine, but for inside a building, it's not really a good solution. So the next was the polymer concrete style, and then that is evolved into the composite plastic that you see here. So the concrete, the composite plastic now is very widely specified, and really seems to be the preference now for contractors, because it's quite a bit easier to work with. It's easier to level and keep perfectly straight, and with the least amount of labor. These polymer concrete systems, they provide good compressive strength and loading characteristics once they're installed. But you can see here on the tongue and groove ends, it can be a little bit tricky to get those aligned and have them stay in place as you're running a full length. So there's an installation chair that the that the channels will sit on to kind of hold it in place, and then you stagger your grates across the joints to provide it a little bit more integrity and to keep them from shifting as much as possible. Shifting is quite common with these in the process of pouring the concrete. So you're obviously the concrete is trying to displace area and trying to move some things out of the way, and as you're leveling it and trying to make it slope properly, you could oh, excuse me, I have to turn that off. So you're kind of fighting that concrete to keep your work straight. So the composite plastic was designed in such a way that the plastic doesn't take any of the structural load. There's a cast iron frame that's leveled and supported fully with the concrete, and then the plastic fastens up into it to keep it in place. So again, the loads are supported by a frame in most cases, and they have the anchor tabs and everything to keep it in place. So they tend to be quite a bit simpler to deal with. So some things to keep in mind are that long sections of U-shaped plastic can sometimes warp in transport or while they're sitting out in the yard, and that there may be some of that shifting and pinching at the top as you're pouring the concrete and trying to tamp it down and get it to perfect level. So some of the things that people do is maybe they'll provide some plywood, or the contractor will put some plywood in the channel to keep it from pinching, or they'll use a cross brace seen in the middle that may or may not stay in after the installation, but again, it keeps that concrete from pushing the plastic into each other. And then there are some where it's actually formed as part of that cast iron frame that supports the channel. So for joining of these sections, and these sections are typically going to be, I don't think I covered it yet, there'll be 4 feet, 4 to 5 feet, and then some 1 foot sections. So there's quite a bit of joining. There's different ways of doing that. When it's, excuse me, on the far right, there's a simple just kind of mounting ear that's formed in as part of the channel, and you put some rods through there, and then just kind of join it together. There are flange joints, there's the tongue and groove types of joints, but all of that affects the straightness of the drain or in the channel. And obviously, if you're standing at one end and it's a little wobbly, it's not as attractive. So
the plain end joint, how does that actually come together then? Because I can't imagine, like, that would seem like a security issue on install.
Yeah, that would just butt up to each other. So
does it have a similar, like with the polymer concrete?
Well, so you'd have that kind of chair, I think, that I showed on the previous, that sits underneath it and kind of holds it in place, but there's not a lot of it's not a positive say a flange joint, which is when it's flanged and bolted together, it's truly locked in place. So,
and for the tongue and groove, is there a locking mechanism as well, or is it just
the tongue and groove, I believe so.
Oh wow.
I don't have knowledge of all the manufacturers of these types, but I believe it is just a tongue and groove. So it kind of clicks in, and the support rods are kind of keeping it together. Part of the issue though with the support rods is that they don't always go in perfectly plumb. You're driving it down and you hit a rock and it's off a little bit, or so.
Yeah,
So
so the flange joint definitely seems a little more secure installed.
the flange is definitely a much more secure way of doing that, because then the mounting rods are really just for, keeping it in place for the pour and not necessarily trying to keep the joints together. So then, of course, there are different materials for the plastic channels that or composite channels that are used in common trench drains. Polypropylene and polyethylene are, the majority of applications they're pretty interchangeable. But if there's significant temperature or chemical considerations, then you might want to consider which one is going to work better for you. Polypropylene usually carries a higher temperature rating, but if you have any concern with the temperature or chemicals, that's a time to check the manufacturer's chemical resistance data. So oftentimes the worst conditions are when they're cleaning. So their cleaning chemicals or the cleaning temperatures are a factor. And when you have chemicals and heat involved, they can affect the pH level. So again, those are one of the first things to consider if there is a cleaning process in the facility, is what's involved in that process to make sure you're specifying the correct material. So.
And I guess an application that we see pretty regularly where, not necessarily to the degree of chemicals you're talking about here, but pool areas, pool applications often come up where they may have chlorine or some other kind of agent in the pool water, or even a saltwater pool can really affect it, right?
Yeah. Well, and a saltwater pool is a chlorine pool. You're just generating the chlorine from the salt that's in the pool, as opposed to adding it. So it's still chlorinated water, salty chlorinated water, but it is still chlorinated water. So those are things to be concerned of. Typically, a pool doesn't have a high concentration of chlorine in it, and so it's less affected than say in the chemical room where they're storing the sodium hypochlorite that they use in a lot of pool applications. So, but typically, if you look at the cleaning process and get the temperatures and the chemicals, you'll make sure that you're specifying the correct material. So, unfortunately, once the drain is set in concrete, it's not easy to replace. So it's always best to get it right the first time. So. So the load ratings, the test standard for trench drain is DIN 19580. It's a European standard, but it's the best choice for specification, and it's currently the only one specific to trench drain. I think there's an ASPE CSA one coming soon, but I don't have full details on that. So. And then other load standards such as ANSI and H2O do not directly convert, but common sense conversions are usually sufficient. So, municipal trench drains and for roadway and bridge conditions are a different product class. So they have, and it's repetitive dynamic loads. So they have different requirements, but these are fairly common load classifications for trench drains. Load class A, pedestrian areas, bicycles, where people are walking. There is B, which is private garages, gardens. If you had a trench drain in front of your garage, for instance, a class B would be fine. Unless you had a motorhome or something like that, you may want to go to class C, but and then D, E, and F. I often see people looking for class E grates inside a facility for because it's considered extra heavy duty. So, and there is another load classification that is specific to interior types of drains, and and they work with classifications of light duty, medium duty, heavy duty, extra heavy duty, and special duty. And they would typically fall in that same, A, B, C, DE for extra heavy duty, and E for special duty. And that is a standard that you would typically see on drains designed for, say, food and beverage facilities, where there's really the type of traffic they're going to see is forklift and that type of thing. So
Yeah,
something to keep in mind.
Actually highlights one of the questions that just came in from the chat here. Just wondering kind of where forklifts fall into that. So trying to answer it there, but
yeah, and there's different types of there's the hard wheel forklifts and the soft wheel forklifts. So now all of these load classifications are based on well, this one here, the DIN 19580. The test is a static load, so it's just strictly straight down, and it you typically see a very significant weight rating with it. The one for interiors is based on a dynamic load, so there could be other forces acting on it. So it has a much smaller number attached to it, but it is again, if you're designed a bridge and only considered that the force would be straight up and down, it would handle quite a bit. But then you add in some moving traffic or a good strong wind coming from the side. Excuse me, that rating would drop significantly. So excuse me.
I know
Another consideration here.
When we get up to like the class F area, that's where we're talking like H20 load rated for say, airports, right?
Yes. Yeah. So the one thing to consider though is that you want to, if forklifts are involved, is consider where the forklift's turning wheels will be, because if they're sitting on a grate, they're putting a lot of twisting on that, and they can cause some issues with the longevity of the grate and also the channel system. So we're trying to find a place to mute while I cough my. Excuse me. I couldn't do it. Sorry.
Yeah, bottom left for you. I'll buy you some time.
Oh yeah.
It's one of those things where like, location and design matters as much as product itself. We covered this if any of the people on the call were in our high traffic application discussion that we did. We do a lot of application discussions for ATS University as well. And in the high traffic areas, like like an airport, your washing facility, it's not always as much the products as it is, say, the design of your entrance or the flow of your of people through that. That's going to it's going to impart on for those high traffic applications as much as the products themselves. The products have to withstand the durability, but how you arrange them, how you locate them, how you locate the other accessories around it, and even right down to how you're doing your entrance, whether or not you're doing an open closed door, or in high traffic areas, you're doing more of like the S pattern opening. So your location and design matters as much as the product itself, even when we're talking about trench drains.
Mm-hmm. Yeah, no, I have seen trench drains where they were right down the center of a warehouse. They had racking on either side, and the forklift driver, rather than turning as he's moving, his turning wheels would be right on the grate, and then he'd be, turning them, and they're kind of banging the grate up against the side of the channel. And unfortunately, that was a channel that hadn't been installed properly, and it started to separate the channel from the floor. So it's again, it's something to consider. I would, if you're looking at the traffic pattern, perhaps have it, closer to one side than the other, so that those turning wheels are out of the way. So fortunately, the turning wheels are right underneath all the weight on the back of the forklift, so it's quite a it is quite an amount of force there. So something to keep in mind too is the hard composite wheels are quite a bit harder on the grates than the pneumatic tires. So with respect to commercial drain gratings, ADA compliance is actually a fairly low threshold. There's no standard code for heel proof. Some say 5/16 of an inch, others say 1/4 of an inch. But usually there's some sort of trade-off between, having it heel proof and having sufficient flow capacity through the grate in order for it to meet the code. So perforated is usually the best choice. As we see here on the right side, and the ADA compliant is really just having that no more than a 1/2 inch wide in the direction of travel. So on the left where we see that 1/2 inch max, as long as that is running perpendicular to the direction of travel, that would be fine. If it was running the other way in the direction of travel, then things like wheelchair wheels could get stuck in there, and that would not be good. So different types of grating materials. Heavy traffic are typically cast or ductile iron grating. Ductile will bend without breaking, so it's if it's a great amount of weight, it will flex a little bit. So, and they are going to show rust. So they're maybe not applicable for a hygienic facility, but just to further mention, the rust is cosmetic. It doesn't reduce the strength of the grate, so even though it started to rust, it's still going to hold up to the traffic. It's really just that aesthetic. It doesn't look as nice as it used to, and hygiene facility, that could be an area that's very difficult to clean. So other grading materials, there's poly grading, really a good choice for animal housing facilities or barefoot traffic. So that's common around the pool decks where you'll see a trench drain all around the pool. Stainless steel grading, again, food and beverage, hospitality, medical, really important in those types of facilities because it's very easy to clean to the sterilized level. And then galvanized grading, you'd see that more in coastal areas because it handles salt air and road salt better than stainless steel or the other materials. So
just a quick question coming in. You mentioned the galvanized there. That might tie into this as well. Relating to parking applications and parking lot applications. We look towards galvanized a lot of time in parking applications, especially in Canada where you're expecting salt. But they're wondering whether or not there's specific ADA graded grates for a parking application. I don't believe there's any differences to the ADA aspect of it.
I don't know that there are specific ADA, but I would imagine there are that there are quite a few that are less than that 1/2 inch. So if we're looking at this grate here on the stainless steel one, that could just as easily be done in galvanized, and that's not a very, very wide slot there. So that would likely still meet the ADA, but I'm not an expert on ADA, so I would recommend checking with each of the manufacturers to see what they recommend. So
Yeah, I know from within our manufacturers, I know there's a handful of grates that do comply with ADA.
Yeah.
And I would imagine, depending on your location, in Canada, you may not want the ductile iron ADA for your outdoor parking application, but in the States, that might be okay, depending on what where you are in the States. If you are you may look more for like the galvanized, which I think the slotted galvanized does have the ADA compliance. But again, that's going to change manufacturer to manufacturer. So the best way to double check would be on the spec sheet, and I can show you how you can find that on our spec tool later on.
Yeah, I know in my line, I don't currently have a parking lot rated grate that is ADA, with the keyword being currently. So
there you go.
That's all I can say. But
we can't even say the brand. We're doing the ASPE CEU.
I know. But I think it was maybe in the opening slide, but I'm sure it's easy enough to find out. So most systems are modular to some point, and most of them are pre-sloped. It's typically the primary function of that sloping is not so much to carry the water, but to carry the solids, so and keep it clean. Especially important if there's organic matter going down the drain. So in food and beverage types of facilities, but also, if you have leaves that are sticking in there and or other types of material, you want to keep that drain clean. So and so that's where the slope is. Most of them are pre-sloped. Some of them will gain some extra length by putting in a neutral section between two slope sections, so they can go longer without needing an outlet. So yeah, like I say, you want to, in the outdoor ones, you don't want stuff sitting there that's going to turn into some dirt to have moss growing or weeds type of things growing in the trench drain, because then it won't flow properly. So most systems can go 100 feet in one direction, but adding outlets along the way can, you could go on for quite a distance. So if we look down here, and the bottom drawing at the top, you'll see we have two outlets. So we could go, if we're 100 feet to an outlet, we could go 400 feet, for instance, by having 100 going to the right to one outlet, 100 going to the left of that outlet, and duplicating that. So and then, don't worry about non-sloped, because it will still flow. The water will still flow. It's just the solids. Typically, they're only a couple, 1 or 2 feet to get to get to a specific run length. 6 inches is a typical width for a channel drain or a trench drain, and there are some other options. 12 inches is fairly common in most materials. In stainless steel, you could have 3-inch, 4-inch, 6, 8, 12, all the way up to 32-inch wide channels. But 6 inches is very common. I would say 90% of what I see is 6-inch. You may go to 12-inch, or where you have the expectation that there may be of high velocity or high volume of water hitting that trench drain. It just gives it more containment area. So typically you can find out what the width and depth should be based on or what the flow would be for different widths and depths through a chart from the manufacturer. So that gives you an idea of whether you can handle a particular volume of water. So where I would see that, in my application being more food and beverage, I see that where, you know, if there's a tank at a distillery that lets go, and they want to be able to contain that in a floor drain, in a trench drain, so that they can treat it. So they'll have, you know, kind of a square rectangle area. There'll be an outlet. The outlet will have a plug most of the time, and then they'll have that channel designed to handle the amount of fluid or liquid that's in that particular tank. So if it's a 20,000 liter tank, that trench drain is designed to hold 20,000 liters. And if there's a catastrophic spill, it will end up in that trench drain. They can then, you know, treat that water to make it meet the requirements to dispose of it to the municipality, or have it come and have you know, a sucker truck come and take that out and treat it. So but all those things are available from every manufacturer. Again, something to keep in mind if there's the possibility that there may be a 100-year storm entering that area, and you want to be able to contain it. You can figure out what that process would be. So outlet requirements, indoors, a rule of thumb is 1 outlet per 120 feet of trench drain. Outdoors, 1 outlet per 80 feet. You know, engineers can specify the size, the number, and the position of the outlet. So, you know, if you have some existing plumbing that you're trying to work around, then you can place outlets in inconvenient spots. And they can be, you know, vertical outlet out the bottom, or even a side outlet. We have the arrow pointing there, going right out the side. So you see that often where it's going into a catch basin, which I think is our next slide here. So there we go. So most of them are drained from the bottom, but catch basin's a way of kind of containing that water and getting it off the floor. And it's also used as a junction box quite commonly too. So where you have multiple runs of trench drain all coming into one outlet box. This would be an area, possibility to have some sort of a basket in there to collect solids, things that you don't want to see, you know, clogging up the pipes past that point. So
it's great at moving debris along, but not all of that debris should be going down the system, right? So having a trash basket in there is a great option. And as well, we'll highlight the modularity. You can see on the side of the catch basin there how it accommodates the different depths based on how long your runs are. So the contractor just punches out and attaches the flange of the trench right to whatever version they need there. And you can see the interchangeability. It's I think 2 SKUs. There's a 24 by 24 and a 6 by 24 by 24. That will allow you to kind of handle all the different variations that can tie into it. So you can see the interchangeability and modularity built into this.
Yeah, exactly.
And then question coming in from chat on the trash basket. Does the basket hold sand? And I think that might be a different product than the one that was shown there, right? There are versions of trench drains that have a basket for sand,
yes,
but not all of them.
That's right. And so in my line, we do have a basket that holds sand.
Oh, I think you muted us.
It's fairly small. Sorry, did you say?
I think you muted up there just as you were. Oh, it's on my side. My internet's.
Okay.
So you go
Yeah.
ahead.
So in my product line, we do have sand buckets, we call them. Now they're relatively small because we don't want somebody straining themselves trying to lift out a large volume of wet sand. But it is basically a solid based bucket with a slot all the way around the top of it. So as the sand enters into the bucket, it settles on the bottom and the water overflows and drains out. So it's not a difficult thing to do, but on a 24 by 24, that could collect a lot of sand before you're lifting it out. It might not be feasible, but you could ask that question of the manufacturer that you're planning to work with if they have something available for it too. So
in general, the base manufacturers, the base trench drains are probably not going to have that sand bucket, but your more hygienic focused products would.
Yeah. So we also have a glass catcher type of attachment for the drains. Again, we're in food and beverage. There used to be a lot of beer that went into bottles. It's going more and more into cans, but eventually I think bottles will come back again because people like to do something a little different. So there are some interesting means available in the market for dealing with solids. So even things like a basket that sits inside of a trench drain in an area where where they're making breaded meats, for instance. Any of that bread material that gets on the floor, you want to try and collect it before it dissolves in your wastewater, because it can lead to some pretty expensive surcharges. So we have baskets that sit inside the trench drain, and anything that makes it into the channel gets supported by that basket up and out of the flow of water, so that you can dispose of it as a solid. So again, I get easily distracted on things I'm excited about. So
I was just going to say, I'm going to give you a 15-minute heads up. We're approaching the hour. If you get you and I talking for too long, any topic, and we can run long. So I'll try to keep you focused here as we wind up here.
So most manufacturers will have a way of dealing with corners. Having them mitered on cider is not always the best way. Some manufacturers, where they're fabricating out of stainless steel or metal, may be able to, do the miter at the factory for you, so it's nice and clean. Typically, you'll see a lot of them where they're just plumbing it underground, as we see here. You come to a point underground is some piping to join this channel to this channel, and away you go. So. And then there are channels that are specifically designed for sports tracks and pools that kind of have the ability to accordion around those curves. So again, an application for everything. So above grade installations, you really need to expect that all above grade drains are going to leak at some point around the perimeter. So we need to have some provision to deal with that water that seeps down. And for point drains, that's usually achieved with a waterproofing membrane. So if we look here at the drawing, we have a drain that's set in a floor. We have a top coating, we have the concrete, and then this black line is a waterproofing membrane. Often it's a sheet, but it could also be a liquid painted type of membrane, and then a clamp to hold that in place. So it's relatively easy to do with a drain like this. Typically, they also have, any water that hits that membrane and makes it to the drain has weeping holes that put it down in the drain, so it goes down the pipe past the P-trap, etc. So a lot more difficult to do with channels, just because of the full length of some of them, running 100 feet or more. So there are a couple of ways that you can do with that. Is you add on, at the outlet, you would tie into the membrane with this type of a clamp added to an outlet. Or if you're lucky to deal with a fabricated trench drain company, like myself, we have developed a system where we can handle that all the way around the trench drain. It's not an inexpensive option, but it's a lot better than having wastewater from the meat department dropping on the produce department on the floor below. So it's a little trickier with trench drains than it would be with point drains. So the other way is to encase it in a slab, or do a two-stage type of a drain, as we've shown here. So we kind of box it out and then tie into the membrane like we do on a point drain at the outlet. So this box goes all the way around. It gets the membrane down the sides, ties into that clamp that is basically the lower half of a drain body added onto the outlet of the trench drain, and then tie that in that way. So again, it's not impossible. It's just needs to be considered when you're specifying. So specify these types of drains. Moving along, shower restroom channels. Really, really common these days to go with a channel drain, or what we would call a shower channel. Makes for a much simpler slope of the floor to the drain, and is quite common now in healthcare facilities, because people in walkers or wheelchairs don't have to deal with that multiple slope of using a point drain. Elevator channels are designed to be installed in front of an elevator. They require a high flow capacity, so if there's a fire somewhere in the building and the sprinklers go off, they don't want that water running down the elevator channel and eliminate, knocking out power to the elevator, eliminating a way for people to get themselves out of the building. So believe this is code in a lot of states in US. We're not seeing it so much here in Canada, but at some point I expect that it will be a requirement. So sorry about that. And then of course you have stainless steel trench drains, that are used in food and beverage facilities, pharmaceutical facilities, a lot going in now into hospital applications, kitchen applications, and they are fabricated, so they can be customized. They can be in pieces as long as 20 feet in one piece. So it's makes for a quick installation, easy to keep it nice and straight because it comes from the factory straight. And not all stainless steel channels are of the same quality. You want to have them flush. You want to have them designed to lock into the floor properly. You want to see how they connect to the floor. It's very important. If you walk into a lot of facilities and look at the drains, like I do everywhere I go, quite often you'll see a separation from the flooring material in the drain where water is getting underneath. So, a high quality fabricated drain is going to take those factors into consideration and make it so that they can be tied in properly. Here where we see this flange that's it's like a 2-inch flange all the way around the channel, allows it to be sealed just below the finished tile floor. So any water that gets through a mortar crack or a cracked tile isn't going to seep down between the trench drain and the floor opening. So look for cross fall in the channel. Look for a pre-sloped. Look at how they're tied together if they're longer runs. Look for sharp angles, interior crevices. There shouldn't be anywhere where dirt can kind of get stuck and become a breeding ground for bacteria. So look at how it's tied into the floor. So we're showing here kind of at the front a couple of the anchor tabs. There should be plenty of those because it's important to keep it locked into the floor. So I left enough time for you to finish here. By now, you should be able to identify applications where the trench drain is preferable to standard floor drains. Highlight relevant considerations for building owners, specifying engineers, contractors, describe the different types, educate specifiers on how to evaluate potential performance, and provide guidelines to help installations run smoothly. So,
Perfect, thank you.
And then I will turn this over to Zach, who has some exciting things on how to easily specify trench drains and other plumbing products. So thank you, everybody. If you have further questions, keep throwing them in the chat and we'll try to get them answered before we're all gone for the day.
Yeah, I'll let you kind of take point and take a look at the the chats that may come in, the questions that may come in. Thanks everyone for spending the time with us. I will try to get this done as fast as possible, but we may run a little bit long. I appreciate, do understand if you need to dip out, but if you do have to leave, thank you very much for spending the time with us that you have today. So yeah, if you are unfamiliar, ATS is available at atspec.com. It's a product selection tool free for architects and engineers to find some of the products that we were talking about today. You can see even before you log in, it is a login service. So you're going to have an account for your firm and your own user account within that firm, which will allow you to share projects, share masters on the system. So if you have a standard set of drainage that you maybe your principal has approved for most projects, you could find and select it here. And then you might have 20 products in that master. Maybe you only need 10 for a project. I'll show you how I can copy those quickly and easy. A couple of pieces we talked about during the intro to the session. From this architects and engineer tab, before you even log in, we do have various templates that are available. So if you're working on a mechanical room, you need a point drain or a trench drain, you'll be able to find that there, as well as your backflow, water heaters, pumps, everything else you might need in a mechanical room, or for a Class A commercial office, or for long-term care, or the high traffic application like we mentioned. That's all available here in the templates tab. From the Learning Hub tab, you have our blogs and cheat sheets for sizing guides, our barrier-free design guides that do a detailed breakdown, as well as our ATS webinars where you can access the previously recorded ATS University sessions. One of the recent ones we did was automatic control valves and the new corrosion protection antimicrobial growth product that just launched, the anti-mic. There was great detailed discussion. I was intrigued to learn how much of a problem bacterial growth is on backflow and control valves or PRVs. Really wild. So to see the solution that Watts came up with is wild. But you can see I'm logged in now. This is, it's going to give your name up here in the top. You can adjust who's on your team. You're going to get some info right from the dashboard in terms of, starting different product selections. With ATS, you start with kind of setting up a folder, and then you can add things to your folder. That folder could be as little as a quick spec where all you do is put in a title for your spec, and then you can start adding it. But one of the keys of the ATS Spec tool is getting a rule engine built into it. So you can put in your project name, your location. From your location, we can start applying the correct building code. So we've been doing big updates on the BC on Alberta rule engine because they just launched and confirmed all their new building codes for 2024. And then selecting your application is also going to assign our rule engine database, and it's going to start recommending products based on that application. We're going to have our masters tab here as well as the ATS templates again that are available here. The difference between the two is our ATS templates are kind of our masters. It's what we would recommend for, say you have a hospitality project, you're working on a new hotel, you may want to start building your master for hotels based on our hotels template. This would work the same for hospitals. You can look at our mental health template and start putting together your own anti-ligature master. And then you can quickly and easily put those approved selections into your individual project. Now, I always assume that I'm going to be running a little bit behind. So you can see I've already got a couple of tabs. I've got my templates here. I've got my trench drain webinar demo that I've set up here ahead of time. And you can see I've got some product selections in here, a couple point drains, a couple of channel drains that are available. Now, what you do in terms of adding these, if you are just adding a new selection, you go to the plus button, hit create new drawing. You'll see we've got, at this point, probably 100 categories of different products that you can add. But you can easily pin your favorites. So you can see if I want to pin this ACV to the top, I'm going to hit that little button. It's going to pin it up here. So my most frequently used categories can be stored for me, next time I log in. You can see as well, I've got the trench drain pinned here. I can get into this category, start using filters to, maybe I want to select my width to only say the 12-inch width. I could do that. It's going to filter that down. I could also, of course, remove any filters, sort by manufacturer. If I want to be looking at, say, Blucher, I can do that there. And I can see my Blucher Hygienic Pro that we've referred to a few times. You can then filter all your additional options. So if I want to select the most popular options, I can do that by clicking the button. It's going to select them. If I then want to add in that sand bucket we talked about, I'll just check that off. It's going to update my mall number as I select these options. If you are unsure what an option is, you can get more detail on any of the products through the website by hitting the spec sheet button. It's going to give you the manufacturer's spec sheet directly embedded into the system. So that's helpful when you're doing things like maybe you want to make sure the backflow that you're selecting has the appropriate flow rate for your project. If you want to confirm, whether the load rating is appropriate on the drain, you can do so there. So I could go through, select and configure everything, add this product. And if there's additional options, we call this a fixture chain that builds up at the top. If there's additional products that help put together a complete combination of products, so think of a toilet where you're going to need your flush valve, your seat, your carrier, and your china. Those are all going to come up as a fixture chain. As you can see here, we just got the one product. I'm going to hit complete. It's going to take me back to that project page. Now, how do I quickly and easily add product into this? We've been working on that for a while. We started launching our templates, and the templates can be a little time consuming still to get all the different sections in. But we've launching this new feature. It actually goes live tomorrow, where you can see I've got a trench drain webinar master here. You're going to have we'll call this our quick access drawer, where you can access your firm's masters, the ATS templates, and your favorite pin drawings. And it's all going to be a drag and drop method. So if I go back to my masters here, and this is what I do. I work with the heads of your organization to help make sure that we get these masters set up on the system so that all you have to do is drag and drop. So if you want help getting your master set up, please reach out to me. I'll be happy to have me or my team reach out. You can see it reorganizes and resequences. The fixture tag is copied over as well. I can close this and go to a brand new drainage master. You can see I've got a handful of products in here as well. But if I want to add let's add some point drain. There's some trench drains to this. You can go back to our master. You could use an ATS template where you could search for drain. We have our drainage master on here. You can expand this and filter through various product groups. These, these three folders are kind of the product groups. You can name them and change them. So if we want to go down within the product group, you can either grab this to drag the entire thing over, or I can grab a single product to drag a single product over. I can drag it down here to resequence things. I could scroll on down, find my clean outs, everything like that. I can go to, let's say we go to our valves and regulators. If I need to add backflow to this project now, this is when you're working on a full project, you're going to go from product group to product group. It's going to load everything up. I can drag this over. Say I need a PRV as well. I know that I've got two PRVs here. I've got my 223BS, 223FS. I'm going to drag this one in, and I'll investigate what the difference is to make sure that I get the right version. I can then double check. I can hit the spec button here. It's going to pop up the spec, and I can investigate to see, is this the right one? What do I need here? It gives you all the details that you could possibly need. Now, if I've got a favorite backflow, I can pin it. And next time I log in, I can go over to my pin drawings, and my backflow is going to be there for me to select. So that's our new quick access drawer feature. You can see how nice and easy it is to go from your kind of regularly used fixtures or your regularly used products. And whether it's your own master, the ATS template, or pin drawings, I don't think there's a better way to start getting product into your project. Once you've added everything you want, you can either check this box. I'll go back to our trench drain tab here. Let's say I just need this point drain or this trench drain. I can copy this over and hit download, and download in any number of formats. I can check this box and download the entire product group. So this would just give me the trench drain webinar demo product group. Or I can check this box, and it's going to give me the drainage mastered product group as well as the trench drain product group. And I can hit download and download a submittal, a schedule in Excel. We've got 3 different versions of written specs. You can download a written spec, the manufacturer spec sheet, the Revit. This is really what I think the best part of ATS is, having not just the manufacturer spec sheet that you could get from going to watts.com, not just the Revit that you could get by going to, say, bimobject.com, not just a static spec sheet that you could get by going to, whether it's the master spec or BDS or any of the other spec pre-written specs. They are not configured to your project. They are not, you're not selecting all the options and getting those configured options together. Same with this middle sheet, where you're going to get very similar to a spec sheet, but downloaded before. So you can see I've gone through, pre-downloaded again. I always assume I'm going to be running late because I know how long I can talk. We can pull up our trench drain written spec here, where everything's open and editable. Now we've got a nice preset piece here. I can copy and paste this and put it into my own written documents. I can open up my manufacturer spec sheet package, which gives a nice title page, nice table of contents with all your tags that you put in, the specific model number that you selected, configured to your project again, and the manufacturer spec sheet if you need the, say, specific design details. I can open up my submittal sheet, where maybe I've got, you can have, of course, your own logo on here. So you'd have your firm's logo on the page with all the options that are available, selected and configured, again, to your actual selection. The Revit as well that I mentioned. So here we've got all the different Revit that we talked about. So we've got our point drain. It gives you the fixture tag that you named it, and it's available for download. So all those are going to be available for download as well. So that's the very quick version of the intro to ATS. I personally love this new quick access drawer feature. I think this is a fantastic system. The biggest key is making sure that you have your masters set up on the system. So you can see we've got, this would be, say, typical for a firm. You might do a lot of condos, and then there might be a different team that's doing a lot of like pharmaceutical and lab areas. You may even break them down by application, say your mechanical room or your drainage, standard use fixtures, like master, say a manual version versus battery or hardwired faucets. You can set up your masters as detailed or minimal as you like. We have some people that maybe they do a lot of work, let's just say McDonald's, Burger King, Starbucks, Tim Hortons. They do work for all those different firms. You can set up your different master for each of them. And then when you've got an EIT who's late in the game, or your project managers behind because they've been spending so much time on HVAC, you can set up your project, copy your drainage, copy your fixtures, copy your water heaters, pumps, whatever, into your project folder, and download an up-to-date version that, if Watts tells us tomorrow, hey, we've changed the model number of our trench drain, your spec's going to be updated, your master's going to be updated. We're going to keep everything updated as much as possible so that you are able to always work from the current information. So that's a very quick version. If you would like a more detailed version, please feel free to reach out to me. We can either do a one-on-one session with you to help you get set up, or a larger session for your firm. If you would like a deeper dive on trench drains, or if you're doing a lot of pharmaceutical projects and you want to dive into more of the specifics of stainless steel channel drains, then certainly reach out to me as well. We can bring Michael in. We can either do a in-person session, or depending on your location, we may jump on a Teams or Zoom call again and provide some of the details that you may need to make sure you're getting the right products. It's always been the core of what we're trying to do, is get the right product, the right application. And I think we learned something today on helping us do that when it comes to drainage. Thank you, Michael. That was fantastic. I appreciate your information there. Appreciate all your details. And at least I always appreciate your stories and the divergences. I think it helps us learn something. So I will always encourage that. Sharing your stories was very valuable for me. So
Exactly.
Thank you for your time. Thank you to all those that joined us today. If you have any questions on the topic, please reach out. If you have any future topics you want to hear, please pass that along to me as well. We'll see you next week for another ATS University. Bye for now.
Bye now.